Welcome to your last lesson of this unit, and this is titled, Are You Normal or Slightly Skewed? Let's take a look. When making histograms, there are lots of different shapes that the histograms can take. The three that we're going to be looking at are these as follows. There's one where the bulk of the data is to the right. That is called a negative or left skew. There is one where it just looks like a hump. It's perfectly symmetrical. That is called a normal distribution. And there is one where the bulk of the data is to the left. That's called a positive skew or a right skew. So be careful with the skewed graphs. When the bulk of the data is to the right, it's a left skew. You'll learn why later, but it's the opposite to the way it looks. Now, because it takes time to draw in all these bars, when we make a histogram, we often just use a curve to show the shape. So there is your negative or left skew. Here is your normal distribution with no skew, and here is your positive or your right skew. So the reason why this one is called a left skew is because the mean is less than the median. So all of these little values down here are pulling the mean down. And that's what's making the mean lower than the median. So because the mean is less than the median, it is negatively or left skewed. Over here, the mean is greater than the median. So all of these big values up here are pulling the mean up. So that makes it positively skewed or right skewed. If your histogram is perfectly symmetrical and looks like this bell-shaped, then it is a normal distribution and your mean, median, and mode should all be the same. This is what is often called a bell curve. You might have heard that term before because the histogram, if you were to just draw the outline of the shape, it would look like a bell. So negative left skewed, mean is less than the median. For normal, the mean is equal to the median, and for the positive or right skewed, the mean is greater than the median. The skew direction is indicated by which way the tail of the curve goes, or by which side of the median the mean is on. So here, the tail is on the left, so it's left skewed. Here, the tail is on the right, so it is right skewed. There are calculations that can be done to measure the amount of skewness in a distribution, but that's beyond the scope of the course. It could be something that you'd learn in a university statistics class. What we're really going to do is examine a normal distribution, because that's what we're going to be focusing on most. So let's take a look at an example. In this example, let's say that our classes marks are normally distributed with a mean of 70 and a standard deviation of 8. So if this was your histogram with all the bars underneath, the bar that contains 70 would be right in the middle. So the bar that contains the number 70, so it could be 65 to 75, or it could be 70 to 80, that's where that bar would be. Now if we added one standard deviation to that, this is where the bar of 78 would be. If we added two standard deviations, so that would be 70 plus 8 plus another 8, that would be equal to 86. That's where the bar would be that contains 86. If we added three standard deviations, so that's 70 plus 8 plus 8 plus 8, that would be where the bar containing the 94 would be. And it would be symmetrical on the left side. So if we subtracted a standard deviation, this would be where 62 would be. If we subtracted a standard deviation, this is where 54 would be. And if we subtracted another standard deviation, this is where 46 would be. Now, in a normal distribution, this would always be true. About 68% of the data lies within one standard deviation of the mean. So when I say within one standard deviation, that's one standard deviation above and one standard deviation below. So 68 approximately, 68% of the people in the class got between 62 and 78%. That is if your data is normally distributed. So if the marks are normally distributed, 68% of the class or of the data would be within one standard deviation of the mean. Within two standard deviations would be 95.5% of the data. So that means 95.5% of the people in the class scored between 54 and 86. Lastly, almost everybody, 99.7% of the data lies within three standard deviations of the mean. So within three standard deviations of the mean is 99.7%. And this is one way where people can discover what is an outlier and what is not an outlier. So almost everybody is within three standard deviations of the mean. So anybody bigger than 94 or anybody less than 46 could potentially be considered an outlier. There's no one correct way of identifying outliers. That is just one theory. So in this example, 68% of our class lies between 62 and 78%. 95.5% of the class are between 54 and 86%, and 99.7% of the class are between 46 and 94. So that's what the percentages are for data that is normal. What we can do is use these percentages and look at an example to discover if this data is normal or not.